In this video we are going to learn about pulsed radar and its operation. Pulsed radar transmits the power in pulses, whereas in continuous wave radar we have seen it transmits continuously. Here we deal with pulses. The important features of pulsed radar are: first is it requires high power to transmit, but whereas in continuous wave radar it requires only low power. And one more feature is pulse repetition frequency plays a major role here. And third one is very important one: only one antenna is used, whereas in continuous wave radar we use two antennas for receiving and transmitting. Here we use only one antenna and will switch switch from one time to other. Like when we are transmitting we use one antenna, and when we're receiving we use the same antenna. So once we define pulse repetition frequency as it is the rate at which pulses are repeated. So as you can see in the diagram of pulse transmission, there is PRT, it's pulse repetition time. It's a time for which the next transmitting pulse starts, or it's a time difference between the two pulses, and 1 by PRT gives the pulse repetition frequency PRF. Okay, now we fastly move on to operation of the pulse radar. Now before going to the block diagram explanation, first we'll get the basic idea of pulse radar. So as it is a pulse radar, one pulse is transmitted, and whenever this pulse is transmitted, the transmitter will be on. Whenever the pulse is transmitted, transmitter will be on. At that time, receiver is off. And whenever we encounter a target, and when echo signal has reached the receiving antenna, then receiver will be on and transmitter will be off for that time duration. So at one instant, either transmitter or receiver, one of them is on and one of them is off. And to determine the maximum detection range, two factors, pulse repetition frequency and pulse width PW, as you can see in the figure of pulse transmission, plays a major role. So now we'll look on to the operation of block diagram. So first part we can observe is supply. Synchronized supply should be given to transmitter, synchronizer, display, and also receiver. And then the next part comes is synchronizer. What does synchronizer do is it sends the start signal to the transmitter, saying that now we have received the echo signal and we have done the operation, so you start transmitting the next pulse. Okay, and so transmitter sends the transmitting pulse, as you can see it's RF signal. From there it comes to duplexer. Here duplexer plays a main important role in the pulsed radar system. So what does this do? Simply, duplexer acts as a switching unit, and even it provides some isolation. How does it act as switching unit? So whenever we are transmitting the pulse, then what this duplexer does is it blocks the receiver, or it does not allow the receiver to participate in the action. Okay, and it sends the transmitting pulse directly to the antenna, making the receiver off. Whenever we receive the echo signal, once antenna receives the echo signal, it blocks the transmitter path and makes the receiver path on. Thereby it decreases the effect of transmitter on the receiver. Why shouldn't transmitter affect the receiver? Because whenever we observe the transmitter, it has transmitted signal will be of high power, that is it will be in the range of kilowatts, some 100 watts or more than 100 to kilowatts. and it is at high frequency. Now whenever we receive the signal or from echo signal is received, this echo signal is of 10 power minus 25 to 10 power minus 28 watts. That means that much low power we are receiving at the echo signal. So the receiver is designed in such a way that it will accept only small powers and it given to a display. Then when the transmitter is affecting the receiver, when the transmitter is operating, and if the receiver is interfering in between, as the transmitter is of high power and the receiver is of low power, it definitely affects the receiver. So in order not to interfere with the transmitter matters, duplexer is used. This duplexer provides the required isolation of 10 power minus 30 watts between transmitter and receiver so that both won't interfere when the action is going on, and duplexer provides that using switching action. Okay, next, main drawback of pulsed radar. See, whenever we are transmitting the pulse for a duration of pulse of PW, pulse width duration, whenever we are transmitting, that means receiver is off, right? Whenever we are transmitting, transmitter is on but receiver is off. So for that duration of pulse width, if the target is very nearby of the same time period or in between the time period of pulse width, like pulse width is, suppose it is like 5 seconds, and your target is at 3 or 4 seconds from the when you're transmitting the pulse, and definitely you're gonna miss that target or you're gonna miss that echo from the target. So what it does is, after 5 seconds, whatever the targets are there, it only receives the echo signal from those targets. So nearby targets which are in between that pulse width duration are not detected. This is the main drawback of pulse radar. Without considering this drawback, even it has more advantages also. So that's all for the explanation of pulsed radar. In the next video, we'll look at the range effect due to power, pulse width and pulse repetition frequency. Thank you.